Hi, I'm Natalia. In this video, we're going to look at a technique called Uncertainty Based Allocation. Let's consider the scenario shown here. We have three fields delivering oil into a pipeline, which is then transported to a terminal. We need to allocate the quantity measured at the terminal back to the fields. There is a simple way to do that, which is to allocate pro rata according to the field's export meter readings. However, the measurements will never be totally accurate because of limitations of the meters. This inaccuracy can be expressed statistically as an uncertainty. There will also be uncertainty due to the effects in the pipeline and possibly other factors. The result is a variation between what the field actually produced and what is allocated, but that's to be expected and is unavoidable. But if the uncertainty of the measurements varies quite a lot between the fields, then it can lead to a situation where one field is disproportionately affected by the uncertainty of the other fields. In that case, using uncertainty-based allocation instead of a simple pro rata will minimize the problem. Let's look at an example. In this scenario, the three fields are producing at a constant rate, but there is variation in the metered volumes because of the measurement uncertainty. Fields A and B are producing at a higher rate, 20,000 barrels per day each, and have uncertainty of 5%. Field C is producing at a lower rate, 10,000 barrels per day, and has a lower uncertainty of 2%. Here is the result of allocation by simple pro rata. For field C, although the measurement uncertainty is only 2%, it is getting a much higher variation in allocated volumes, of around 5%. That's because it's being affected by the higher uncertainty of the other fields. That is the problem with this method. Field C gets no benefit from having a more accurate meter. Now here's the result of the uncertainty-based allocation. The variation for field C is much lower, so it is allocated close to its metered volume. That's shown here by the blue and pink lines being close together. For the other fields, like field A for example, there is very little difference between the result of the two allocated methods. The pro rata allocation is blue, and the uncertainty allocation is green. So how does the uncertainty calculation work? Let's have a look at this AXIS audit log, which shows the detail of the calculations. Step 1 is the simple pro rata. The allocation factor is the ratio of the terminal volume to the sum of all the field's metered volumes. Step 2 is the uncertainty-based allocation. This time, we calculate the difference between the terminal volume and the sum of the field volumes and weigh it according to the field's uncertainty using this formula. So a field with a low uncertainty is allocated less of the difference, and a field with high uncertainty is allocated more. That means more of the variation is given to the fields with the greatest uncertainty. This is a better result overall, and it also encourages more accurate metering. In practice, the most difficult part is to work out the uncertainty of the measurement because it is often affected by a lot of factors. If that can be done, then uncertainty-based allocation is a simple technique that can avoid issues like the one we saw here. That's all for now, and I hope you found this video useful. Thanks for watching.